What if you could unlock your front door with your hand, rewrite your genetic code like editing a document, control a computer with nothing but your thoughts? For some people, these aren't science fiction fantasies, they're Tuesday. Welcome to the bleeding edge of human enhancement. Today, we're diving deep into the world of extreme biohacking, where the line between human and machine, natural and artificial, safe and dangerous, becomes increasingly blurred. Biohacking used to mean tracking your steps or trying a new diet, but a growing community of self-experimenters has pushed far beyond that. They're implanting chips in their hands, editing genes in their garages, and literally connecting their brains to computers. Over the next 30 minutes, we'll explore 5 of the most extreme biohacks happening right now. We'll meet the people pushing these boundaries, examine the science behind their methods, and ask the crucial question: just because we can hack our biology, should we? But first, a warning. Everything we're about to discuss carries serious risks. Some of these procedures are illegal, unregulated, or downright dangerous. We're not recommending any of these practices, we're simply documenting them. Let's begin with something that might already be living under someone's skin right now. This tiny glass capsule contains an NFC chip, the same technology in your smartphone that lets you tap to pay. But this one isn't going in your wallet, it's going under your skin. Meet Amal Grafstra, often called the godfather of implantable technology. He's been living with implants for over 20 years and has 6 chips in his hands. His company, Dangerous Things, has sold thousands of these chips to people around the world. As Amal puts it, these chips have completely changed how he interacts with the world around him. The technology is surprisingly simple. These chips use near-field communication, the same tech that lets you tap your phone to pay at a coffee shop. When you bring the chip close to a compatible reader, it transmits a small amount of stored data. No battery required. People use them to unlock doors, start cars, store medical information, share contact detail, even make payments. It's like having a digital business card that's always with you. The procedure itself takes about 30 seconds. A trained professional uses a large gauge needle to inject the chip between your thumb and forefinger. It's about as painful as getting a vaccination. But is this safe? The immediate medical risks are relatively low if done properly. We're talking about infection, rejection, or migration of the chip. But bioethicists raise bigger questions about privacy and autonomy. Once you can be identified by simply walking past a scanner, what does that mean for your freedom? Critics worry about a slippery slope. If chips become normalized, could they become mandatory? Could employers require them? Could governments track citizens through them? Supporters like Amal argue that technology itself isn't good or evil. It's how we choose to use it. These chips give users more control over their digital interactions, not less. Currently, chip implants exist in a regulatory gray area. The FDA doesn't approve them for human use, but they're not explicitly banned either. Companies like Dangerous Things and Sweden's Biohacks International operate by selling research devices and leaving the implantation to trained professionals. But is convenience worth the risk? And more importantly, is this just the beginning? Because some biohackers aren't content with just adding technology to their bodies. They want to rewrite their genetic code entirely. For most of human history, we've been stuck with the genes we were born with, but what if you could edit them like a Word document? Delete a disease-causing mutation here, enhance a beneficial trait there. Welcome to CRISPR-Cas9, the genetic scissors that have revolutionized biology. And now, you can order a kit online and try it yourself. Meet Josiah Zahner, perhaps the most notorious DIY genetic engineer. A former NASA scientist turned biohacker, Zahner has made headlines for his public self-experiments. He once injected himself with CRISPR live on stage at a conference trying to edit his myostatin gene to increase muscle growth. Did it work? Probably not. But, as he says, that wasn't really the point. Zahner's company, the Odin, sells genetic engineering kits to anyone with a credit card. But before you panic, we're not talking about editing human embryos. Most of these kits work with bacteria, yeast, or frog eggs. Still, the same principles apply. CRISPR-Cas9 is essentially a molecular search and replace tool. Originally discovered in bacteria as an immune system against viruses, scientists Jennifer Doudna and Emmanuel Charpentier figured out how to program it to edit any DNA sequence with unprecedented precision. Their work won the 2020 Nobel Prize in Chemistry. The process is surprisingly straightforward. You program the CRISPR system to find a specific DNA sequence, like using Control F in a document. Once it finds that sequence, it cuts the DNA. Then you can either delete that section, replace it with something else, or let the cell repair itself, sometimes with beneficial mutations. Zahner believes this technology should be democratized. Why should only scientists and fancy labs have access to genetic engineering? His kits let anyone experiment with the building blocks of life for a few $100s. But this democratization terrifies many experts. Dr. Jennifer Doudna herself has expressed concerns about DIY genetic engineering. The Harvard Law School's Petri Flom Center has written extensively about the bioethical minefield we're entering. The most infamous case involves He Jiankui, the Chinese scientist who shocked the world in 2018 by announcing he had edited the genes of human embryos, resulting in the birth of twin girls. The global scientific community reacted with outrage. He was sentenced to 3 years in prison. This case highlights the ethical precipice we're standing on. CRISPR is incredibly powerful, but it's also incredibly unpredictable. Off-target effects could cause cancer or other serious problems, and once you edit the human germline, those changes get passed on to future generations. Most countries have strict regulations or outright bans on using CRISPR technology on human embryos. But enforcement in the DIY space is nearly impossible. Anyone can order these kits online and start experimenting. Is this the ultimate form of self-improvement or a terrifying step towards a future we can't control? The answer might depend on how comfortable you are with ordinary people having access to the power of genetic gods, but editing genes might seem tame compared to our next topic. Literally merging human consciousness with machines. What does it mean when your thoughts can control a cursor on a screen? When your mind becomes part of the digital world? Welcome to the realm of brain-computer interfaces, where the boundary between thought and action dissolves entirely. Brain-computer interfaces, or BCIs, work by detecting the electrical signals from your brain and translating them into commands a computer can understand. It sounds like science fiction, but it's happening right now. Let's start with the most famous example, Neuralink. Elon Musk's company made headlines when they announced their first human patient, Noland Arbaugh, was able to play video games and move a cursor with his mind after receiving a brain implant. Noland was paralyzed from the shoulders down after a diving accident. The Neuralink device, called the N1 implant, was surgically placed in his brain. After recovery and calibration, Noland could control a computer cursor just by thinking about moving it. He played chess online, browsed the internet, and even played video games, all with his thoughts alone. But Neuralink isn't the only player in this field. Researchers like Dr. Frank Willett at Stanford University have been working on BCIs for years, focusing on helping paralyzed patients communicate and control devices. Their work has enabled people to type at speeds of up to 90 characters per minute just by thinking about writing. There are two main types of BCIs, invasive and non-invasive. Non-invasive BCIs use external sensors like EEG headbands to read brain activity through your skull. These are safer but less precise. Companies sell EEG headbands that claim to help with meditation or focus, though their effectiveness is debated. Invasive BC requires surgery to implant electrodes directly into the brain tissue. They're much more precise and can detect individual neurons firing, but they come with all the risks of brain surgery, infection, bleeding, and potential damage to brain tissue. The potential applications are staggering. Beyond helping paralyzed patients, researchers envision BCIs that could treat depression, anxiety, PTSD, and other mental health conditions. Some even imagine a future where healthy people use BCIs to enhance their cognitive abilities or directly interface with the internet. But this technology raises profound questions. If your thoughts can control machines, can machines control your thoughts? What happens to human agency when our brains are connected to computers? And who owns the data generated by your mind? There are also practical concerns. Current BCI technology is still experimental and unreliable. Signals can degrade over time as scar tissue forms around the implants. The brain is incredibly complex, and we're still barely scratching the surface of how it works. Despite these challenges, the field is advancing rapidly. The FDA has approved several clinical trials for BCI devices, and companies like Neuralink, Synchron, and Paradromics are racing to bring these technologies to market. For people like Noland Arbaugh, BCIs represent hope and independence. For critics, they represent a dangerous step toward a future where human consciousness itself becomes hackable. The question isn't whether this technology will advance, it's how we'll choose to use it, and that choice might determine what it means to be human in the decades to come. Speaking of redefining human limits, our next biohack takes us inside the cellular machinery of life itself, where voluntary starvation might hold the key to longevity. Could voluntarily starving yourself be the key to a longer, healthier life? And at what point does a biohack become a dangerously obsessive practice? Welcome to the world of extreme fasting and autophagy, where biohackers are pushing their bodies to the brink in pursuit of cellular renewal. Autophagy literally means self-eating. It's your body's internal recycling system, a process where cells break down and recycle their own damaged components. Think of it as Marie Kondo for your cellular structure, clearing out what no longer serves you. This process happens naturally, but fasting can dramatically accelerate it. When you stop eating, your body doesn't just burn fat for energy. It starts breaking down old damaged proteins and organelles, essentially giving your cells a deep clean. The science behind autophagy is legitimate. Japanese scientist Yoshinori Osumi won the 2016 Nobel Prize in Physiology for discovering the mechanisms that regulate autophagy. Research shows that autophagy plays a crucial role in preventing cancer, neurodegeneration, and aging. But biohackers have taken this research and run with it far beyond what scientists might recommend. We're talking about fasts lasting days, weeks, or even longer. Dr. Walter Longo from the USC Longevity Institute has researched what he calls the fasting-mimicking diet. His studies suggest that periodic fasting can regenerate immune cells, reduce inflammation, and potentially extend lifespan. But his protocols are carefully designed and medically supervised. Dr. Rhonda Patrick, a well-known researcher in the longevity space, has extensively studied the benefits of fasting and autophagy. Her research suggests that even shorter fasting periods can have significant health benefits, including improved insulin sensitivity and cellular repair. But extreme fasters go far beyond these scientific protocols. Some biohackers fast for 7 days, 14 days, or even longer, consuming nothing but water and electrolytes. They report increased mental clarity, spiritual experiences, and dramatic health improvements. The risks, however, are serious. Extended fasting can lead to electrolyte imbalances, heart arrhythmias, kidney problems, and even death. Your body needs essential nutrients to function, and prolonged deprivation can cause irreversible damage. There's also a psychological component. The line between biohacking and eating disorders can become blurred. What starts as an experiment in optimization can become an unhealthy obsession with control and purity. Medical supervision is essential for any extended fast, but many biohackers go it alone, relying on online communities and self-monitoring. They track ketone levels, heart rate variability, and other biomarkers, but they're essentially experimenting on themselves without proper oversight. The autophagy community argues that modern medicine is too conservative, that doctors don't understand the benefits of fasting because there's no profit in telling people not to eat. They point to historical and religious fasting traditions as evidence that extended fasting is natural and beneficial. Critics argue that we simply don't know enough about the long-term effects of extreme fasting to recommend it. The research on autophagy is promising, but most studies are done on animals or cell cultures. Human studies are limited and often involve much shorter fasting periods than what extreme biohackers attempt. So, is fasting the ultimate biohack for longevity, or a dangerous game of cellular Russian roulette? The answer probably lies somewhere in between. Moderate, supervised fasting protocols show promise, but the extreme versions practiced by some biohackers venture into uncharted and potentially dangerous territory. Medical supervision is essential for any extended fast, but many biohackers go it alone, relying on online communities and self-monitoring. They track ketone levels, heart rate variability, and other biomarkers, but they're essentially experimenting on themselves without proper oversight. The autophagy community argues that modern medicine is too conservative, that doctors don't understand the benefits of fasting because there's no profit in telling people not to eat. They point to historical and religious fasting traditions as evidence that extended fasting is natural and beneficial. Critics argue that we simply don't know enough about the long-term effects of extreme fasting to recommend it. The research on autophagy is promising, but most studies are done on animals or cell cultures. Human studies are limited and often involve much shorter fasting periods than what extreme biohackers attempt. So, is fasting the ultimate biohack for longevity, or a dangerous game of cellular Russian roulette? The answer probably lies somewhere in between. Moderate, supervised fasting protocols show promise, but the extreme versions practiced by some biohackers venture into uncharted and potentially dangerous territory. Our final biohack takes us into even murkier legal and scientific waters, where tiny doses of illegal substances might hold the key to enhanced creativity and cognitive performance. Is microdosing psychedelics the ultimate creative hack? Or are we just scratching the surface of a dangerous unknown? Microdosing involves taking subperceptual doses of psychedelic substances like LSD or psilocybin mushrooms. We're talking about doses so small they don't cause hallucinations or obvious psychoactive effects, roughly 1/10 of a recreational dose. First, let's be absolutely clear. These substances are illegal in most countries. LSD is a schedule. A controlled substance in the United States, meaning it's considered to have no accepted medical use and a high potential for abuse. Psilocybin mushrooms are similarly restricted in most jurisdictions. That said, there's a growing underground movement of professionals, artists, and entrepreneurs who swear by microdosing for enhanced creativity, focus, and emotional well-being. The practice gained mainstream attention largely through the work of Dr. James Fadiman, often called the father of microdosing research. Fadiman has collected thousands of reports from citizen scientists who document their microdosing experiences. His research suggests that people experience increased creativity, better mood, improved focus, and enhanced problem-solving abilities. Silicon Valley executives, artists, and academics have reported using microdoses to enhance their work performance. They claim it gives them the creativity boost of psychedelics without the time commitment or intensity of a full trip. Recent scientific research is beginning to validate some of these claims. Studies from institutions like the University of Toronto's Psychedelic Studies Research Program suggest that microdosing can indeed enhance creative thinking and cognitive flexibility. But here's where things get complicated. Most of the evidence for microdosing benefits comes from self-reported surveys and anecdotal accounts. Placebo-controlled studies are difficult because people often know when they've taken a psychedelic, even at low doses. The few controlled studies that exist show mixed results. Some find modest improvements in creativity and mood. Others find no significant differences between microdosing and placebo. And we have virtually no data on long-term safety. This is particularly concerning because we're talking about powerful substances that affect brain chemistry. Even at low doses, psychedelics interact with serotonin receptors throughout the brain and body. We don't know what repeated exposure over months or years might do. There are also practical concerns. LSD and psilocybin are often obtained from unregulated sources, so users have no way to know what they're actually taking or in what dose. What someone thinks is a microdose could actually be much stronger, leading to unexpected and potentially dangerous experiences. The legal risks are also significant. Possession of these substances can result in serious criminal charges, job loss, and other life consequences that far outweigh any potential benefits. Despite these risks, the microdosing community continues to grow. Online forums provide detailed protocols, dosing schedules, and safety advice. Some users follow the Fadiman protocol, dosing every 3 days to avoid tolerance. Others prefer different schedules based on their personal response. Supporters argue that the current legal framework is outdated and that these substances have tremendous therapeutic potential. They point to legitimate research into psychedelics for treating depression, PTSD, and other mental health conditions. Recent studies from institutions like Johns Hopkins and Imperial College London have shown remarkable results using full doses of psilocybin to treat treatment-resistant depression. This research has led to breakthrough therapy designations from the FDA and renewed interest in psychedelic medicine. But therapeutic use under medical supervision is very different from self-medicating with unknown substances obtained from illegal sources. The therapeutic protocols involve careful screening, preparation, supervised sessions, and integration support. Microdosing typically involves none of these safeguards. So where does this leave us? The preliminary research on microdosing is intriguing but far from conclusive. The anecdotal reports are compelling but uncontrolled. And the legal and safety risks remain significant. Perhaps most importantly, we're still in the very early stages of understanding how these substances work and what their long-term effects might be. What seems like harmless optimization today could have consequences we don't yet understand. As we've seen throughout this exploration, the world of extreme biohacking exists at the intersection of human ambition and scientific uncertainty. From chips under the skin to genes edited in garages, from minds connected to machines to bodies pushed to their limits, biohackers are rewriting the rules of human biology. Each of these practices represents a different approach to the same fundamental question. Can we improve on millions of years of evolution through technology and self-experimentation? The chip implants offer convenience and digital integration, but raise questions about privacy and autonomy. DIY genetic engineering promises to democratize the power of evolution, but risks unleashing forces we can't control. Brain-computer interfaces could restore independence to the paralyzed and enhance human cognition, but they also blur the line between mind and machine. Extreme fasting might unlock cellular renewal and longevity, or it might be a form of sanctified self-harm. And microdosing could enhance creativity and well-being, or it could be a dangerous experiment with powerful substances we barely understand. What unites all these practices is their practitioners' belief that the current limits of human biology are not fixed. They see the body not as a temple to be revered, but as a system to be optimized, upgraded, and enhanced. But optimization for what, and at what cost? Each of these biohacks carries risks, both known and unknown. More importantly, they're taking place largely outside the traditional structures of medical oversight, scientific review, and regulatory approval. This isn't necessarily bad. Many medical breakthroughs have come from researchers willing to experiment on themselves or push beyond conventional boundaries. The problem is that individual self-experimentation can't answer questions about population-level safety, long-term effects, or optimal protocols. As these technologies become more accessible and more powerful, we'll need to grapple with fundamental questions about human enhancement. Should these capabilities be available to everyone or only to those who can afford them? How do we balance individual autonomy with collective safety? And what kind of society do we want to create when human biology becomes programmable? The biohackers we've met today are early adopters, pioneers pushing into uncharted territory. Some will undoubtedly face serious consequences for their experimentation. Others might discover genuine breakthroughs that benefit all of humanity. But perhaps the most important question isn't whether these specific biohacks will succeed or fail. It's whether we can develop the wisdom to use these powerful technologies responsibly. As technology gives us the power to hack our own biology, the biggest question isn't whether we should, but what kind of humans we want to become. The choice is ours, and we're making it right now, one biohack at a time. The future of human enhancement is being written in underground labs, online forums, and the bodies of willing experimenters. Whether that future is utopian or dystopian may depend on how well we can balance human ambition with human wisdom. What do you think? Are these biohackers pioneers of human enhancement or cautionary tales of hubris? The conversation is just beginning, and your voice matters. Let me know your thoughts, and thanks for joining me on this journey to the edges of human possibility.